20.2 types of organic reactions, and really this is a really good opportunity to kind of summarize some of the stuff that maybe you've been doing in the preceding unit 20.1, getting together some of those reactions that you've seen and seeing how the homologous series are linked. Now this diagram here is rather scary, but it's an attempt to put together a lot of the reactions that are very common at this level in organic chemistry. But it also serves as a way for you to maybe see, well, if I wanted to start from this compound here, I've got a way in which I can make this compound here, and these are the steps that I would take to get there. And so that's a synthetic pathway. And an example question here might be, how can I make ethyl ethanoate, which looks like this, if I only have ethanol to begin with? So ethyl ethanoate, there's my ethanoate bit, here's my ethyl bit. What could I start to make that from? Well, how do I make ethyl ethanoate? It's an ester. I'm going to start with an alcohol, and I've got ethanol for that. And I need a carboxylic acid, so that's going to be ethanoic acid, looking at that. So to do that, CH3COOH like that. So those two reactants would react in the presence of some concentrated sulfuric acid. I can make my ester. However, I've got to think, well, how do I make this stuff if I've only got ethanol? Well, ethanol can be oxidized up using potassium dichromate, acidified. And if I want to go right through to the carboxylic acid, I need to remember that that has to be done under reflux, and that will give me that. So I take some ethanol, convert it to the carboxylic acid. With the remainder of the ethanol, I can then react my new product to make my ester. Now, in, say, the pharmaceutical industry, something like retrosynthesis plays a very important factor, and that's where they'll have a target molecule in mind, very complicated drug that they want to reach, and they will work back from that step by step. Right? So incremental changes back to a much simpler starting material, and very often they will use some form of computer programming to help them find the best route, the fastest route, the one that's going to give the best yields. There we go.